two students out of blue light. Yeah. Okay. So it turns out this is very similar to what this is. And it turns out we can rewrite this triangle as 0, 2, 0, 1, 2, 0, 1, choose 1, 2, choose 0, 2, choose 1, 2, choose 2, and so on. Basically, you have all of the combinatorials in a nice little triangle. If you want a proof of this, you can think about it like this. So we're going to do a thing called block walking, which is at each turn. So for example, let's say we wanted to get to this point from this point. Well, we're going to need to go, and like at every turn, you have to go down, but you can either go to the left or to the right. So we're going to need to go down exactly once to the left and exactly once to the right. That's 2 moves, and one of them is a left. So that's going to mean that you have to choose 1 from 2 to be the left one, and that's 2 choose 1, which corresponds to here. It's kind of a bad example, but basically, let's say we wanted to see how many ways we could get here. So we need to go to the left 1, 2, 3 times, and we need to go to the right 2 times. So you have 5 steps, and you're choosing 2 of them to be to the right. So if you look at this diagonal right here, you notice, well, this is 1, that's 2 choose 2. This is 3 choose 2, which is 3. This is 4 choose 2, which is 6. This is 5 choose 2, which is 10. And we're going to get 15 here, and then 21. Have any of you seen these numbers before? Brian? Oh, sorry. Sorry, I saw your hand. Okay, so what's 1? What's 1 equal to?
1 plus 0.
1 plus 0, which is 1. What's 1 plus 2? 3. What's 1 plus 2 plus 3? 6. What's 1 plus 2 plus 3 plus 4? 10.
Why aren't you using the equal sign?
All right. Okay, so basically we see that these sums are the same as what's in this row. And if you want a proof of that, you can look at Gauss sums. And do I need to prove that?
Maybe just finish.
Okay, all right, I'll just finish it. So we want to find B and C such that B choose 2 over C choose 2 is equal to 1/2. Okay, so we notice that these are the same as the sum of the first n numbers. Like this is the sum of the first B plus 1 numbers. This is the sum of the first C plus 1 numbers. Or sorry. This is the sum of the first B minus 1. This is the sum of the first C minus 1. So let's start looking at some of the first n numbers.
So the ratio you're looking at is the number of pairs of blue-eyed people divided by all possible pairs.
Yep.
Is that right?
Yep. All right, so let's look at the sum of the first n numbers. Okay, so the first one is 1, obviously. The second one is 3. Then 6. Hey, 6 divided by 3 is 2. So that means the answer must be 4, right? Well, it would be kind of weird to have a class with 4 people at school. So, yeah, that doesn't really make much sense. And the question even says there are at least 2 answers. Try to find the one that makes the most sense. So we're going to go on. Okay, so then we have 10, 15, 21, 28, 36, 45, 55, 66, 78, 91, 105, 120. I'm going to skip ahead. The sum of the first 20 numbers is 210. 105 divided by 210. That's 1/2. And if C is 21, well, 21 choose 2. That's equal to 21 times 20 divided by 2. This is equal to 210. And 105, well, that's 15 choose 2. Because 15 choose 2 is equal to 15 times 14 divided by 2. Well, 21, that sounds kind of close to what I was saying earlier. Like the average class has about 20, 25 people. So I'm going with 21 here. This is kind of a subjective question because if you're in a really big class, you could have much bigger numbers, bigger answers. But yeah, this is the answer I want to pick.
I think that's a good answer.
Great.
So is there any argument from the other team? So your answer was 21 students total, and
Yeah.
15 of them have blue eyes, right?
Yeah.
Okay, cool. Great. So no argument? So we get 14. This might be our last turn as the other team, so do you guys want to challenge or go for another problem?
What do we bring? Go for it. You want to do that?
Okay. Which problem would you like to do?